Hello everybody. We are going to start a new unit of IGCSE Computer Science, okay? The unit known as Computer Hardware and Software. I hope we will have a very fruitful journey here, okay? So let's start, okay? What we are just going to discuss about here, okay? So we are just going to master IPO. We will just understand function machines and once again, okay, we will have just a short revision of flowcharts that we studied in the chapter 1, okay? So overall, okay, what we have to just understand, computer just works with some abstract logic rules, okay? Logic governing data manipulation, okay, with and, or, and not that works inside the processor, okay? Then we have gotten the stored program concept that we have to discuss about in this chapter. What that is and why that is important, okay? Instructions in data are loaded into memory prior the processing, okay? And the physical implementation of that, okay? How is the instructions performed or executed inside the computer, okay? We will be just talking about the different physical parts and their roles in the computer, okay? So first of all, we have to understand the input process output model, okay, or the IPO model. IPO model simply says that, yeah, every computer operation must have these three parts, okay? Every computer overall, okay, it takes an input, it processes the data, and it just gives as an output, okay? So input, that is like entering data into a computer system. Process, changing the meaning or format of the data, and output, displaying or outputting processed or stored data to the user, okay? So that is any machine that takes input from the user or environment, processes that, it means just it makes changes to that and gives an output, is a computer, okay? So any machine at your home or just anywhere you can see that takes some inputs, processes that, and just in any format, okay, it simply gives an output to the user or to the real world. That is a computer, okay? So we have gotten embedded machines in printers, okay, and embedded systems in printers, in cars, in remote controls, okay? We have gotten that in washing machines, your mobile phones, okay? A keyboard. So all of them just simply, they take input, they just process the data, and after that simply they give you any output, okay? For example, if you just take the example of the keyboard, so you press some buttons, okay, or just alter the controls here, so that is just your input. Then based on that, okay, the system or the embedded system inside the keyboard processes that data and just gives output in the format of sound to you, okay? So overall we can say, yeah, this is this kind of a type of computer. Or washing machine, okay, it has gotten some buttons that you can just give input to it. It has gotten some sensors inside it, okay, that can sense different things, and based on that, just then it will work, and it will control the machine to just make some movements, okay? So the output will be in the process of some movements or things like that. So IPO in real world, as we just told you, the IPO system is present in any system, okay? So we have gotten general purpose PC. So here just input, the input is just given to a general purpose PC with keyboard, with mouse, actions or things like that. The process of operating system handling multiple complex tasks simultaneously. So the process, the data that you just give to the computer will be processed by the instructions of the operating system and with the hardware, okay? And output, okay, screen rendering and varied output. So it has gotten just different types of outputs, okay? It has gotten display that can just show you things, speakers, or just many other forms of output, okay? Then embedded system, okay? Overall, what is embedded system? Microprocessor dedicated to a single function inside a larger mechanical system, okay? The example for that is just washing machine. And inside this, yeah, the input for this is the button presses, weight, and water sensors, okay? Then process strict water regulation and cycle choreography, okay? So that is processed, and output motor spinning, heater activation. Okay, so there is one thing about the embedded systems, okay, compared to general purpose PCs, because general purpose PCs are more complicated because they are just designed to perform different tasks, uh, and embedded systems, they are just designed to perform any specific task. Okay, they just are much simpler compared to general purpose PCs, and they use less power, and they just need limited memory, and they are just simply highly customized. Okay, they are just customized to perform specific tasks. See, there is just a metaphor for this IPO, okay, function machine, okay. Simply it says that, yeah, it works like a function that takes an input, then after that just it processes that input, okay. For example, here the input, if that is 3, then yeah, multiplied by 2 and plus 2, and the output will be just given to us as 8 here, okay. So this function machine has to be quite deterministic. It means a set of mathematical or logical rules is applied sequentially to input to produce highly predictable outputs. Okay, so 3, there we have gotten some mathematical or logical rules that are applied to that sequentially. First this one, then the next one, then the next one, then a predictable output is just given to us. Okay, then algorithm is required here. Okay, so a sequence of precise steps is mandatory to turn input into meaningful output. Okay, so we just need algorithms to just change the format or the meaning of the input. Then the only input process output system just works with very simple tasks. Okay, but as algorithms become more complicated, the system must keep track of its working. Okay, it has to just keep the data that it has worked on. Okay, so when that is just needed, we would just simply need some memory and storage to just keep the data between the process steps before the final output. Okay, so we will just simply need that in modern computers we have gotten RAMs and caches, things like that for that. Then algorithm, we have just studied in the first chapter, okay, what algorithm is. Then we just discussed about different ways to present algorithm. Here in this video, once again, we are going to talk about the flowcharts. So see, the problem is, okay, natural language or just English is ambiguous, okay, and it is highly prone to misinterpretation. If I just simply write things in sentences, maybe just people just take different meanings from that. Okay, so the solution is, okay, we translate abstract logic into strict standardized diagrams. Okay, so what is the benefit of that? Simply that prevents logic errors, guarantees universal understanding among engineers, and allows for precise debugging before physical implementation. Simply, if we just tell engineers that, yeah, you can write the algorithms in natural language or natural English, maybe just one engineer will just write it one way, the other one will just write it another way. Okay, so simply making a standardized diagram will help all engineers just simply understand what is going on, and it prevents errors. And although we just do not need to just talk a lot about this, because we have talked about them in the first chapter quite in detail. Okay, but again, just, yeah, we have gotten some specific shapes used for specific purposes. Okay, for example, the shape of parallelogram is used for input and output operations, and the square is used for processes. So as here you can say input user password, it means just, yeah, at this step the software or the program will take an input from the user and store it inside user password variable. And here, yeah, we have gotten calculate total equals price multiplied by text. Okay, so that we have got. Okay, and exam warning, never mix these up. Okay, so each one of these shapes, they are just meant for their own specific tasks. Okay, if you mix them up, you will just simply lose some marks. Then let's just discuss about some exam pitfalls. Okay, So you should be careful that, yeah, you should never confuse IPO with CPU architecture. Okay, in CPU architecture we use FDE that we will be just discussing in the future, but overall, okay, input process output is used for overall computer system. Okay, so you have to just know. The reality is the FDE that we will be just studying in the next videos explains how the CPU fetches instructions from RAM and just executes that, okay? But the IPO model explains how data flows through the entire computational machine, okay? So never write, fetch, decode, execute on a general system computational model, okay? For general system computational models, you'll just simply write IPO. Some questions are here, okay? Some Edexcel IGCSE practice questions are here. So let's see, can you just guess the answer or not, okay? After each question, you just simply have to pause the video, find the answer, or just write your own answer. Then after that, play the video and compare the correct answer with your answer, okay? To just check yourself as well. Question number 1, a user uploads a new profile picture to a social media app. Describe the input, process, and the output of this action. So here you have to describe input, process, and output. Pause the video and play again. Good. So here is, okay, the input is uploading a file, that is the input here. Process, so social media app compresses the image, okay, and it resizes the image. And the output will be just, yeah, displaying updated picture on your social media. Question number 2 for 2 marks. Explain why a complex function machine requires memory. We answered this in the video. Pause the video, write your answer, then come back. Good. So the answer is to store intermediate calculations and keep track of machine state, or to keep the work result between steps, okay? Question number 3, identify the correct flowchart symbol for a user typing their password. Good, that is parallelogram. Some tips for your exam. The first one, okay, always use a straight edge ruler for flowchart lines and arrows. Slopy diagrams lose marks, so be careful about that. When you're just going for your exam, take a ruler with yourself. Then choosing embedded examples, the safe list, okay? Be careful, okay? Try to use examples that are present in the textbook or just in this video that we have shown you, okay? To safely secure marks, only use textbooks examples. For example, thermostats, washing machines, hospital equipments, factory equipments, or anti-lock brakes, okay? So they are just there. And the danger list, do not use a kettle or a standard fridge as an example of an embedded system unless you explicitly state it contains a microprocessor, because some basic models do not. So if you just write it, maybe just you will lose the marks, okay? So you have to master the vocabulary, okay? Draw with precision and respect the IPO boundaries, okay? So that's it for the first video. Wish you all the best for the entire journey of computer hardware and software chapter. Goodbye. Good luck.